active-active versus active-passive. Two shapes of the same sentence. We have a second one, and only one of those shapes is actually serving traffic right now.
2 in the morning, a payment service, one database, and a second identical machine sitting right next to it, copying every change as it happens. Then the first machine's disk controller dies. No warning, no slow decline. It just stops answering. And you had planned for this. There is a second machine right there, fully in sync. It has been in sync for 10 months, and the service is down for 41 minutes. Not because the standby was missing, not because the data was gone. The standby was fine the whole time. Every one of those 41 minutes was spent switching over to it. So here's the question this whole video answers. You had a second server. Why were you down for 41 minutes?
The subject is redundancy, and specifically the two shapes it comes in. Active-passive, the second machine waits, kept up to date, and gets promoted when the first one dies. Active-active, both machines take live traffic all the time. We are going to cover 4 things: what each one actually is, in code, the failover itself, which is 4 separate steps, what each shape costs you, honestly, in both directions, and what a real system usually looks like. This is not backups. A backup is a copy of yesterday. This is a copy of right now. It is not about adding capacity, which is horizontal scaling and a different video. And it is not about any one cloud provider. This is the shape that sits underneath all of them.
Before any code, one picture, because it kills the confusion most people have. Think of a building with an emergency generator in the basement. It is fueled, it is serviced. Once a month, somebody starts it for 10 minutes with nothing plugged into it, ticks a box, and switches it off again. That building is active-passive. Now think of a building fed by 2 power lines from 2 different substations, each carrying half the load all day, every day. One line fails, and the other picks up the rest. Nothing starts up, nothing gets promoted, the lights do not even flicker. That building is active-active. And here's the part that matters. In the second building, you already knew the second line worked because the lights it was powering were on. The proof was the service itself. In the first building, the generator has proved that it can start. It has never once proved that it can carry the building.
So, active-passive in code. 2 machines and a configuration file with addresses from the range reserved for documentation, so nothing here is anybody's real network. One of them is named primary, the other is named standby. Now look at the routing function, the thing that decides where an incoming request goes. It returns the primary. That is the entire function. There is no branch in it, there is no condition. The word standby appears in the config, and then it never appears again anywhere on the path a request takes. Look at the health check as well. It only ever asks about the primary. Nobody is asking the standby whether it could serve a request, because nobody ever intends to send it one. That is what passive means. The second machine is invisible to production until the day you need it.
When the primary does die, the system moves through 3 states, and it is worth naming them because people say failover as if it were a single instant. Serving. Everything normal. All traffic going to A. Suspect. The health checks are failing, but you are not sure yet. Was that the machine, or was that the network between you and the machine? And promoted. You have committed. B is the primary now. Then there is the transition nobody plans for. The old machine comes back. It still has your data. It still believes it is the primary. If it starts accepting writes again, you now have 2 primaries and 2 different versions of the truth. That last arrow is where most real failover incidents actually go wrong. Here are the 4 steps as code. Step 1, detect. 3 failed checks, 10 seconds apart. 3, not 1, because a single mischeck is usually just a network hiccup, and promoting on a hiccup is worse than waiting. Step 2, fence. Before you promote anything, you have to make certain the old machine cannot accept another write. Cut its network, revoke its credentials, power it off, whatever you have. People skip this step, and skipping it is exactly how you end up with the 2 primaries from the last slide. Step 3, promote. The standby applies whatever changes it had not caught up on yet and then opens itself for writing. Step 4, repoint. Every client in your system is still holding the old address. Until they let go of it, the promotion has changed nothing that they can see.
So let us add it up. For a failover where everything is automated and nothing goes wrong, 30 seconds to detect, 2 seconds to fence, 15 seconds to promote, and 60 seconds for the new address to reach the clients, because 60 seconds is how long they were told to remember the old one. That is 107 seconds. just under 2 minutes. And that is the good number, the one you can defend in a design review. The number in the story at the start was 41 minutes, and the difference between them is not technology. The difference is that 2 of those 4 steps had never been run before, so somebody had to work out what they were while the site was down.
Which brings us to the uncomfortable question. Your standby has been sitting there, in sync, for 300 days. In that time, your service handled about 2.5 billion requests, and the standby served 0 of them. So what has it actually proved? A few real things, and they are worth monitoring. The process is running, replication is keeping up, there is disk space. But now look at everything it has not proved. That the promote command works while the machine is under load. That the address change actually reaches your clients. That your application reconnects instead of sitting there holding a pool of dead connections. That the alert wakes up a human being. Every single one of those runs for the first time during your worst hour. An idle standby is an untested standby.
Now the same 2 machines, active, both of them are in the pool. Both have a wait. The routing function asks which ones are healthy and picks one. And notice that it asks about both of them, every second, forever. Now watch what the failure handler does. It sets a flag to false. That is it. There is no promote, there is no fence, there is no address change, because the address was never pointing at a machine, it was pointing at the pool. When node B dies at 2:14, 3 seconds later, the healthy list has 1 entry in it, and you are running at 50% capacity and 100% availability. And here is the quiet part. That same line runs every single time you deploy. The code that handled your outage had already run 1,000 times this month.
That is the real argument for active, and it is not the one people usually give. People say it is about capacity or about being closer to users. Both of those are true, and both of them are secondary. The actual argument is that active deletes the failover procedure, instead of trying to improve it. There is no promotion step to get wrong because nothing is being promoted. There is no fencing problem because there is no single writer to fence. And the second machine is continuously proven to work, for the very single reason that it is working. If it were broken, you would have found out on an ordinary Tuesday afternoon, and not at 2 in the morning.
So why does anybody still run active-passive? Because active-active is not free redundancy. It is a trade, and you should hear the bill before you sign it. On the left, what it takes off your plate. No promotion, no fencing, no address change, no path that has never been executed. On the right, what it hands you instead. 2 machines are now writing at the same time, so you own conflicts. Anything you were keeping in memory on one machine has to move somewhere both of them can see it. Your capacity planning changes, because with 2 sites, each one has to be able to carry the whole load alone, which means each one normally runs at half. And you have to answer a question that active-passive never even asks you. What happens when the 2 halves can each still see your users, but they cannot see each other?
Let us make that conflict concrete, because a consistency problem sounds abstract until you watch one happen. One product, 10 units in stock. 2 customers each buy one, 40 milliseconds apart, and they happen to land on different machines. Machine A reads 10, subtracts 1, writes 9. Machine B also read 10, subtracts 1, writes 9. Last write wins, so the stock is 9. 2 sales, 1 decrement. You did not get an error. You did not get a conflict warning. You got data that is quietly, plausibly wrong. The fix is at the bottom. Every row carries a version number, and a write has to say which version it believes it is replacing. If somebody moved first, you refuse the write and raise a conflict. That is 1 extra field, plus a real decision about what your application does when it fires.
And now the hardest one, split brain. The network between your 2 sites breaks, but both sites are perfectly healthy, and both of them can still reach users. So each half looks around, sees no partner, and quite reasonably concludes that the other one has died. So both keep serving, both keep writing. And when the link comes back, you have 2 divergent versions of the same data, and no automatic way to say which one is real. The standard answer is a quorum. You need a majority in order to keep accepting writes, which is why these systems are built with 3 nodes rather than 2, so that a split always leaves one side in the minority. The side that loses the vote stops serving. Being briefly unavailable is something you recover from. Being briefly wrong, silently, very often is not.
So which one should you actually build? Almost certainly both, in the same system at different layers.
Your web servers, your API processes, anything that does not remember anything between one request and the next, run those active-active. They have no conflicts to have, so you get all of the upside and you pay none of the bill. Your main database, the single source of truth, active-passive is usually the honest answer there. One writer, one version of the truth, a replica standing ready. That is not a compromise. That is the right tool. The thing to take away is that this is a decision you make per layer and not once for the whole company. Anyone who tells you their entire system is active-active is describing the front of it.
Here is the sentence I would keep. You are not choosing how many machines you own. In both designs, you own two. You are choosing whether failing over is a routine or an event. Active-passive makes it an event, a procedure that runs about once a year, at the worst possible moment, carried out by a tired person reading a document. Active-active makes it a routine, a flag that flips, on a path that already ran today. And if you do keep an active-passive tier, which you probably should, then the only honest thing to do is to fail over to it on purpose, on a Tuesday afternoon, while everybody is awake.
If that filled in a gap, hit like and subscribe so the next one finds you.